Okay, today we're gonna do some effects. The last time I showed you the procedure modeling with the simple RBD simulation, right? And I'm going to show you today still RBD simulation with character movement. Okay, let's go with that and bring the one of the character from anywhere. But I'm going to use the modeling here. So where's the modeling? Zombie characters. I think so. Let's do the zombie. Where is the zombie here? I want to find out zombie characters. Where is the character? Oh, that's a simple. Okay, mocap biped. Select that. I can find that out. And also you can just zombie make it, and you can change um the texture like this. Okay, this is more like zombie types. Let's play with this one. Okay, this is fine. If you want to reduce the speed, then you can go ahead like this and play. Oh, okay, here.
Very good. That's it.
Okay. No, so
Did you silence this time?
you can find out the character and biped, mocap biped. Change the texture and just in place the animation turned off. Then you can see here. This is a this is a preset of the zombie character, right? Then definitely this one will have the some information inside of the box, right? Then if you go inside, then you can see all the gray box with this one. But why this one is more like a gray? It looks like we cannot use it, right? Then yeah, but if you right click here and allow editing of contents, then you can see there's unlock the image here. Go inside, then you can see the properly, something we can edit. All right. This is all the spline which is a skeleton system. You don't need to worry about this stuff. And there's a material and chops, maybe which is animation. This is a geometry. Then we can go inside there. So now we can see here, uh, just go back to the object mode, and this what it is. This one is the ghosting other object. Hide other object means when you turn off, there's nothing is happening. Then you go inside, and even if there's outside something is there. For example, sphere. You do have a polygon here. That's a polygon. But when you do the ghost here, go inside, then we can still see that the outside of this mocap box, right? But if you click the hide other object, means it's gonna hide. And here, then we can see both of them. When you go inside the sphere, the outside of the zombie will not showing up, which is a ghost. But usually, when I work on that, I want to focus on this, so I just hide that. Just hide like this and go inside and go inside again. And you can see this one, you can bring it up. So I'm going to use this part, but I want to put this on null here to just out. Okay, and select that, and just going out and create the geometry box, another box here. Let's say this one is FX RBD, something like that, and just change the color. Just press the C button and change the color. All the effects will be here inside there. So nothing is coming out, right? When you go inside, there's nothing. But when you go inside and you're gonna bring the character, object mode, object merge, and let's say this is in character. Okay, you can change the different color with the color like this, and go inside, and go inside the mocap, and now we know that which one is geometry. We just created the null as an out. Bring it up, and you can see. Yeah. Boom. Okay. So you ready for that? So this is the one we just set that out, and I will explain the little bit about the RBD simulation. Okay. Here, RBD simulation is rigid body simulation, but we are using the blast server. What is a blast means? This is we call the pack primitives. This is from the game industry. They to make that the RBD simulation much light. So we bring that technology into the VFX in actually the Houdini. Here, let's try that. Let's create just really simple the box first. Okay, simple box. Create that here, and just copy this and paste it. Then you can match the size of this here, same like this, and position of the y-axis here, and divide 2, which is half point. And always we get the even if that's increased. Oh, sorry, what's going on here? Okay, divide 2. Okay, and every time whenever we just increase the y size to hit that on the ground. Okay, then here 2, 2, something like that. A little bit. Let's make this on 5 something. Okay. So I want to break this. I want to cracking this the shape. How can we do that? Using yeah, there's multiple different way. Okay. So let's do that really simple one already pre-built material fracture. Material fracture. RBD material fracture. If we put that in and select that, it's a little bit calculating that this is like a Voronoi fracture types of concrete. Select the explode viewer. Then you can see what happened here. Then you can see that the all the fracture is happening in there, right? So just less here, a little bit less, and let's open that a little bit here. But you know what is the problem with the Voronoi fracture? It's to clean everything. We want to make that some noise pattern on there, right? How can you do that? Maybe there is something in there, right? So go there and you can check that out, the edge detail. Select that out and really be overthinking. Oh, there's edge and we can see it, right? So this is quite the noise height and frequency is really big. Maybe you can noise element size maybe it's bigger, like a 6. Then you can see there a little bit less noise on top of that, right? And look at I think it's the 4. Okay. If you feel that the interior detail is too much, too many, then you can reduce that interior detail, which is the detail size. I just want to make the 2. Then you can see they're like a 2, something like that. The 1.5, for example, which is good. But if you feel that is not enough, I wanna make that a little bit higher amplitude of the noise, then you can increase this one too. Then maybe you can get a little bit more shape on it, right? This is simply you can create the noise pattern of this. But another one, you can add some kind of chopping here, right? Also interior detail, which is interior detail means here. There's more detail you can add that inside there. already you have some interior stuff, but we can add more interior detail. Let's check that out here. You can see there's some additional noise pattern on that, right? Maybe amplitude to reduce that. Then you can see something different here. You know, this is up to you. Without this, with this, a little bit different, right? And we can see it. Everything's there, just like this. So this is quite useful. If that is a simple geometry and that is not really heavy geometry you are working on it, this is good. This is good for the fracturing. And I wanted to add some chopping. Then here, chipping here, enable chipping. Then you can get the smaller, chipping stuff here. This one also can be as a smaller geometry. You can change that, the seed number, and maybe you can add that little bit, the 9 here. You can get the more, right? If you change that, it's 1, something like that. This one is less. Like I think let's do that some 9, smaller. And the area is too small. Maybe you can do like a 8. Then you can get the more wider area of chipping stuff here. Then we can get it. Then let's bring it together. Boom. Right? Okay. This is the one that we just create that. Oh, but I think I want to make that a little bit more the fracturing point here. How can you do that? Maybe you can increase this scatter number, right? So let's make it this one 10. It's more scatter point, then you can get the more. And there's a one more tap there, another 10, and you can get another fracture shape. That's a lot more, right? Then just go ahead here, then you can get it. So what is a material fracture? There's 3 different buttons here. This is high resolution. This is a constraint. This is a low res version. Let's check that out. Which one is? That's null here. This is still high res. Get that one. Just click this guy. Copy. This is we call the low res. Okay. Then what's the difference to high res and low res here? Let's see. So nothing really changed that. Oh, okay, here. You see? That's a lot changes, right? Now this and this and this is different, okay? But they share the same name attribute, okay? You see it? Same name attribute here. This is also same name attribute. Let's check that out. Name attribute is same. This is a P000 or something, whatever. This is also some really different name on that. Oh yeah, there's a name. You can share that. All right. So that is very important. Later, I will explain that without using this RBD method fracture, you should have the same name attributes. Otherwise, we don't get the proper resolution, proper simulation on that because we sim it with this low res. The later apply this transform data onto the high res. This is how the RBD solver is working. For example, RBD solver here. Actually, that's the one geometry constraint here. This is a proxy version of it. So inside the proxy, the right click and allow editing of the contents. Then you can go inside. You see, wow, there's a lot of things, right? There's a number 3. It's proxy geometry is coming into there. Usually this one is 1, which is we bring these guys into here. And group and packaging everything and go inside and everything there. This is the one, see? This is the object. This object is a kind of low res object, which is explode viewer here. You see, this one is low res, right? This is going into the first input. Then let's go inside the first input, what that is. Here, thus usually this is the source data, which is this RBD. So here, this is the first input, okay? This RBD input is first input, which is low res data. So we are going to bring this data and sim it. Then later, this output goes down here, and as a point to represent, which is just when we get the point, is including all the transform data, and also this point will drive the high res data, which is this. Okay, this is high res data, and everything goes down, and later we can see here this high res data from drive by this transform pieces, which is the point is there. High res is data here. Then this point will drive this high res static data. Can you get it? All right. This is so complicated, looks like. So I will show you that how this one is working later on. But this is a kind of concept of the RBD server. So that's why they do, the proxy geometry and the high-res geometry comes together and combine them together working in here. So whenever you're using the RBD bullet server, you have to use this both data with the constraint as well. Okay? All right, good. So here, like I mentioned that we don't use this part here. Let's try that we create the assemble how do you call it? That's assemble here. Assemble here. Let's say this is the concrete. Is that correct?
Yeah.
Yeah. Okay. This is a concrete, and we put the new name on it because the name attribute to what this one has this piece 000 something. We just make sure that this is concrete of the name attribute, and let's see. Let's change the name of the name attribute is changed as a concrete. Okay, but the need to be same attribute should be here. Like I mentioned that this one and should be the same. So high res and low res has the same attribute. Okay, and like I said, we don't use this one for simulation. We're gonna use this one for simulation. But let's make that another one. Assemble data here. Just you don't need to check anything. Just check create the pack primitives. You can also do that here, but I just prefer to separate that because later you can use this one as creating some constraint or whatever. So here, let's say this one is pack. This one is create the name, okay? So you don't need to pack this part, but here you can do that. And just let's make this really simple RBD server with the DOM-net, okay? DOM-net here. Let's say this one is first simple, like we see that in the RBD server here. Okay, this is a RBD server. Let's say RBD and press the button and color like this. And let's go inside. Where's there's a pack primitives. That is what we see before, right? Then here, what we see is first context. Oh, there is, right? And we do have a blast server. Okay, just connect them right down here. Let's play. Then what happened? Nothing is gonna happen because there's no force and anything. So let's make the gravity here. Okay, and let's make the ground. Merge. Let's connect them. Just change the switch here, and just let's do the play. Boom. Oh, it's kind of it's working now, right? Boom. That's what we're doing now here. this is a first step we have done it, but still this one is the low res simulation, right? Then it's going back here and top import, which is we have seen it. Top import is here. Then top network is there, and also we just get this let's change the RBD object. Okay, you can copy this and just go there, paste it. Okay, and oh sorry, just this is wrong. Top import. Okay, this one, not top import field. Top import here. Just go drag and drop. So another one here. RBD object copy. Paste it. And when you select, then we can see only this part. There's no more ground, right? So but still we can see checking and ground and everything. Right? So but usually we do simulation like this, but we need a high-res geometry, right? We don't need that the low-res prox geometry, which means we need only pack, the primitives, the transform data only from the pack. What is a pack means? The last time I mentioned that the pack is the similar like a point, but only there is a transform data in there. Did you get it before? Did I mention that? Right? And which means we don't need this geometry. Geometry, which means, geometry is in the visually we can see that, but we don't need that. Only we need transform data, which is a create point and the represent point, represent object, right? So then we can see this part here, and when you check that out, then all the orient value and pivot data and the name attribute, everything is there. Okay. That's the thing. And we just cache them out, okay? File cache here. And let's say this is a cache with the RBD point. And let's make that this one is a smaller amount of the frame, just 100, okay? And just cache them out. And save that first and cache it. Okay. Did I do that? Okay, there's a cache here. Then you can get it here like this. We have all the transform data with the point, and this is the one we need to match this because we rather than using the geometry, why we are doing this? This is a that you can check the size of the file is extremely small rather than just caching the geometry. That's why it's very important to keep these points, especially if you work on your own. So here, transform pieces, which is this, and just bring that high-res geometry. And second is the template point. Last one is a rest position, which is the first frame, is a static position. So time offset, time shift here, and just first the frozen frame, which is this, and keep that it. Bring that out here, and just select that out. Oh, okay. What's going on here? Something is wrong.
What's the time shift for?
Yeah, time shift is the just frozen frame rest position. Okay, so this is first frame. We have to keep that it, but it's still, everything is right, but it's not working properly. What's going on? What do you think? Is that because of the pack?
Yeah.
Let's try that.
Something about being packed, I would assume.
Let's try that if that is working. Oh, not working. What's going on? Here, you see, this is a 1040, right? Point. This one, something 1201. Well, why is that? Why is that different here? This high res and low res. Because the when they pack it something they have or some different method they're using it. So maybe we have to bring this data to there, which is this. This attribute here, transfer. We can do the attribute transfer from here to there, I think. Attribute transfer. Let's try that with that and the only name attribute here. Yeah, I think that's the one we can try. And I think that's the one. And let's try that here. If that is working, oh, that's not working here as well. Just pack, copy. Oh, something is going there, right? Try that. I think there's something almost here. What's going on there?
Oh. You feel great.
What about the opposite here? Something like that. And we can just cache them out. Everything is there. How's yours? Maybe yours is better or not?
Oh, probably.
Can try that. Let's play. Oh, something is working, but some eye is not moving. Right? But why this one is working? But this guy is kind of working, right? So without this, let's try that without this guy. Just without this and without this, and there's a pack is there still, right? Then just try that, cache them out again.
How did you get past the gosh?
Just let's keep going on it here.
I'm still having issues with the attribute transfer. What did you do?
You don't need to do the attribute transfer. Just we do use this one here.
It's back.
Yeah, this is exactly matching that. You know, I think there's somehow difference between high res and low res is matching in there. Somehow they do have some, filtering here, which is there is somehow so they matching the all the material. I mean the geometry, even the low res and high res, and matching them together. That's good. That's why we don't need to add any the name attribute on there. We just keep the attribute from there, which is good. So here, then we can use it. We can keep that the previous name attribute. Just keep that it. Yeah, we don't need this guy and the caching them out and everything is done.
Yeah, I think it's not even.
Oh, really?
Yeah. Oh, actually, sorry, I missed it, but it's not even over. I don't know. I might have missed spots.
Okay, here, that's good. Here, that you should check out. You don't need this anymore. Okay, this only we pack and the name. We can keep the name from the battery structure, and we can send that out. Let's go and play working, and here let's play there. Things here. It's good. It's good. Schema. Okay, just break that out here. Schema cancel. That's working now, right? Thank you. The same thing?
No, it's so nice.
Okay, that's fine. Yeah, it's okay. Just keep that in and keep this, create a path. Just so you create a patch in, that's all. And we don't need that. And also you don't need this one. We just pack these guys from there. And you know that this is stuff import you need to think, oh, okay, that's a lot of different stuff you do that here. Stuff import, okay? And just drag and drop here. Go inside. Oh yeah, just drag
you select this one and drag drop. Select and you can see this area and just drop. Yes. And here, just copy it. And just paste it here. Then you can get the final result, but this guy need to have a person which is doing that the previous here, right? You can go inside and then you can get the result here. Yeah. You see? Then, but we're gonna just get the point here, right? Bring it here. Yeah, this one should be possible. And the time shift, and then you need to cache it in. This is the rest cushion you need to add. Rest cushion, it means that do you know what is a rest cushion means? Okay, let me explain that. What is the rest cushion means? Yeah.
All right. All right, guys. Do you guys know what is the rest position means?
Rest what?
Rest position. Why we need the rest position? In this, when you use the Houdini, you need to understand what is the rest position. Why we need that for. For example, here, sometimes we need to calculate that based on this rest position and something. Here, let's create some grid pattern here. And it's not grid pattern, sorry, the maybe box. Another box here. And I want to make that the same thing. Okay, I'll just copy that, just same thing. Let's copy this. And here, I will create the the line here. And also here. And also there. And this is the one I have. And also there's a bend. You got it here? And the bend there. And when you see the bend here, you can see this is the one. Then you can see it. But let's check that out. How this one is. I think it's better we put this guy here 0 and 0, and maybe the capture area is a little bit higher. Then you can get this kind of animation based on that. So here, this is a bend like this. Let's try that. This is sine function with this and frame and multiply 10, something like that. Then I think you can put that this one is the 0.2, for example. Then play. Oh, that's too slow. Let's do that 1. 5. Oh, I think it's too slow. Let's do the 10, for example. You don't need to worry about that to learn that stuff. I just want to explain why we need the rest cushion. This is very important to understand that when you do shading, okay, with the noise pattern. Okay, this is moving, and there's a point bob. Point bob, you can use it. So you know how to texturing. Have you learned that in the texture course and line course? How to make the UV, right? So based on UV, whatever this guy is moving, no problem, right? But if you use the procedure, the noise texture, if you want to use that, that's the different point-based procedure noise pattern. If you're using, that's the different. So here, what that means is here, I'm going to create the turbulence noise with this and just 3D noise on that, and just change the color. And this is based on position, and connect them with the color. And now we can see it here. And when you play, can you feel that it's like a sliding now? Just I will show you that a little bit more. I will increase that the 20. 20, something like that, and 50. Then let's see here. Can you feel that it's like a sliding, right?
Mhm.
But actually it's not sliding. It's actually noise pattern is in there. Just only object is moving, right? But looks like sliding. But how can we make this guy stick on the geometry? That's the question, right? So RBD simulation is also always looking for some first initial position with that and so bring the old data into there. So now this time we need a rest position. Okay. So I want to use the rest position and stick on the geometry whenever wherever this character is moving, and I want to use it. So that's a geometry, but this is a geometry that before animating. So we need to find that out. So there is the rest position T pose you maybe you may seen before, right? T pose on the character. Every time the character modeler they made that T pose, we call that's the rest position. So this is like I said, this is T pose and rest. Yeah, rest position. Let's put that in. If that is not moving, then you can just connect that. Then you can get the rest position here. Then here, let's say rest position. Yeah, see? There's a rest position, we can see it. Right? Rest position and T. This is P and rest position. This is nothing is moving, that's okay. But when you bend, whenever it's moving, that's the position is keep moving, but the rest position is not moving, right? So we can use this rest position when we apply the texture, which is rather than this position, just bind. Okay? The position is the vector data, which is a rest position, rest. Then instead of using this P, we can use this rest position here. Put that in. Why you put that just only rest, not rest position? Because we create the attribute as a rest. If you want to put the rest position here, then you can change the rest position later. But here, let's see. Can you feel that? It's a stick, right? This is very important concept. Whenever using the rest position, which is very important when you apply the texture on the fluid effects. Fluid is always moving, but you need to get this kind of rest position, sometimes multi-rest position for the texturing. So need to understand what that is.
What's a multi-rest position?
That's when the fluid is stretching a lot, then the texture is stretching a lot.
Oh,
So
okay.
another texture is covered that's kind of blending. That's the techniques of the when you're using the multi-texture rest position, that kind of things. So this is a rest position. Why we need that? Because the rest position initial position, how much far from the rest position to there. This is always calculating from there. That's why it is happening now here. Then also we can check that out. Whenever it's happening, the fracturing is happening, then we can decide that like there's a rest position is there. For example, this is moving later here. Then we can calculate the between there. Oh, this is how far from this guy, right? We can remap the distance based on that. For example, point triangle here. Okay, this position is something like from the rest position here, second input here, then two position, point 1 P, PT none, which is from I get this rest position from there, input there, and let's say this is a rest position as well. So vector rest position just as it is. Then we bring this one is rest position and the P minus this rest position. Did I explain that what is a vector addition, subtract, that kind of things last week? Did I or not?
We touched on it.
Okay, CD. So here you can put that it also, let's say fit function. You don't need to worry about that, this part, okay? Just 1, 0, so for example here. What I'm going to show you here, and that's white, everything is white. When they close each other, it's gonna white. But when this guy's far from the original position, it's become black. Okay? What we can make it? Maybe kind of secondary debris we can make it. Oh, that's far enough, then just make it some fracturing like that. This is how the debris source is working. Debris source is some kind of, calculating some this kind of effects. Or some fracture of windows. For example, the Windows there's a window is there, but we have to create the free-fractured window, right? But the problem with the free-fractured window is that when you apply the material fracture or volume fracture, there's an inside face is there, right? Which means when you render this is a really opacity render, you have to do that, right? The transparency render, you're gonna see that. So you can see all the fractured glass inside there, which is not good. But if you use this kind of technique, you can check that out. Oh. What is it? Okay, we're working. Did you catch that out? Yes, you did. Get it? Oh, this is fun. And here, I have the different name on. Oh, that's okay. I think it's working. No, this is only for the color. This is color for that. This is the one with position fit the CD and blah blah, and this one should be the minus. Right? All right. Did I mention what is the length of the? Did I mention the subtract and addition, factor addition before? No.
You did vector addition, but we simply did touch on it.
All right. What are the Johnson told you guys the vector addition and dot product and cross product, that kind of things? No? Okay. So right. Okay. Then this is one of the techniques we can use it, right? So this is the one that we have to use it. Okay, this is cool. Already you know that, right? Another one. Let's bring this guy again. I'm gonna save that out.
Sorry, I'm trying to understand. What did you do in that point wrangle at the end? The attribute wrangle.
That's I calculate the distance between them. Here, this is point, right? That this is a rest position, and this is a moving point, right? And here, boom, like this, but this is a rest position, and this is moving point. I calculate that the distance between the 2 points.
Okay.
Here, but this is the subtract. P minus rest position means that subtract from the moving point and original the rest position, and then we'll generate some vector, and I just calculate the distance. If you call that the length function between them, then you can get the length of the vector.
Right.
So
Fitting them.
yeah, we fit it into there and apply into the color. So which means you can represent as a color
So
based on distance.
so that function at the top, the point function.
Yeah, so the point function to there.
What is that?
Okay, so why we need that this for? Because I just want to explain that what is this, why they using the rest function. That's sometimes they need to calculate between the rest function
Yeah.
and that
No,
kind of
yeah,
things.
I get that absolutely.
Mm.
I just wanna what like the point function does in the vex expression.
Mm. Do you wanna you wanna understand that what it is? That's what you mean?
Because the vector rest position is equal to point.
Point one, which is bring this point data into there. One means a slot number.
Right.
0 is first is second is third, third is 4.
Yeah.
That's the thing. All the data bring this position data to there, which means we bring the rest position to
Okay.
store in there. We bring this store in there position and the minus from the original point, which is not the rest position, right? It's a moving point, and between there's a subtract. That's why you guys need to understand what is the vector subtract means. But you haven't heard that before. When you learn that. Okay, then you need to understand that what that mean is here. No.
Okay, I think I get the second part. But yeah.
Okay. So that's the thing. I will explain that later a little bit about the vector addition, vector subtract, and dot product kind of things. That's gonna be much more interesting than just writing down. Okay.
Yeah.
All right. Cool. That's another thing. So here, that's quite long. Here, let's copy that and let's make another RBD simulation here. So now we back to the old school way. Okay, that's what I like usually. Let's go with that and the Voronoi fracture. Okay, this is old school. And scatter point. When you do scatter, then you can use the only scatter or something. You can add some volumetric data in here, some BDB from the polygon, which is that, and change this as a density. Connect them, just make this one as a density and create the particle from there. Then you can fill the inside the volume here and turn off. Then something is randomly you can generate that. Without this volume, what happened? Just scatter on the surface itself, right? Just based on the surface geometry. If you want to add that inside the volume geometry, then you can add that like this to the volumes. And here, I want to make this like just like a 20, okay? Point here and just connect them. Only fracture here. This looks like similar like what we did, right? And
What did you remove in scatter? Did you do something in scatter?
scatter? Oh, scatter, there's a relax iteration. That means the relaxation is off, means just randomly generate that.
Thank
you.
Okay.
All right. It's really hard to follow. Too fast.
Let's start. No.
All right. Okay, good. All right, then we can check that out here. Extrude viewer, okay? And go there and just check that out here. But this is not enough geometry here. That's the problem. So, but we have to create some geometry outside there and also interior detail. We have to do that. There's a lot of things we need to do that, right? So here, yeah, we can increase the number of the geometry. Let's say 20, 20, 20, maybe more of 50, 40, 40, to make that out here with a higher resolution here. I think I like this one, okay? And there's more. 60. Okay, I like that much here. And just fracture, the result will be the same, okay? But there's no interior detail, you can see it, right? We need to create that interior detail for that as well. But before we go that, I want to make this some kind of noise pattern in there. How can we do that?
Attribute noise.
Attribute noise, can you do that? Okay, let's do that. Attribute noise.
That's
Sorry,
it.
can you go to Broadway Fracture?
Mm. Okay, here?
Just change it.
No? There's nothing. When you change the number of the point, which is 15. Oh, sorry. 6. Where is it? Is it 15?
They're all the same thing.
Oh, sorry.
You might.
Sorry. Scatter. Scatter point is 20.
Thank you.
Sorry. It's not Fourier fracture is nothing we changed that in the Fourier fracture.
Yeah.
And this one is also prefix the pieces, the name attribute will be generate that, but we don't need to worry about that. Yeah. Okay?
Yeah.
So let's try that the for shaping. I think there's a noise pattern. Let's add that. Add noise. That's what you said. Noise, attribute noise here. Let's try that. And put that in. This one should be P, right? Okay, we add that this P. Amplitude here, S here, something like that. Okay. But the problem is here. Yeah, see? Actually we want to keep this geometry. But this one is, this is changing something, right? That's not what we want. Something, but you're really very close, close to answer. But we're gonna use this technique anyway, like you mentioned that. But you know that even if we tweak that, still the line itself is clean. It's not really noise, right? We can think about that. Okay, there's a noise pattern is there. What if we just change the shape of the noise between the original position and rest position, which is rest position and this noise pattern? We can subtract them. You know that this is very important concept. Can you guys understand what I'm saying here? This is noise pattern. Okay, this is the this is not good. Here I'm just get the noise something Jira center here. Let's make that's not good here. Okay, this is good. Okay, here let's say that this is shape that we create here. Okay, this shape and this shape. Okay, that's why we have to understand that this part here. Okay, this is a minus subtract from original point and other point, right? So here, between original point and other point, there will be some gap between, right? We store this data from the original point and the moving point, deformed point. We subtract them and we store this data into somewhere and bring it back. So I will show you what it is here. You can point triangle, okay? Point triangle is here, and we bring this guy is original data here. Okay, the same thing here. Then, like I did, point and 1 P genome, which is we bring the second data. Second data is actually original data, okay? So here, this is what we call that subtract from position, okay? And let's say we deform. Right. So we store this data into here, okay? There's some data in between, subtract. And we bring this deformed data in there and just cache them out, bring it down, right? Everything is there. And we bring it back. This data, we just subtract from this noise pattern. Just let me show you something here. Point triangle. Okay, still this is noise pattern, but we bring the V form. This is the data we can do it, but from the original position for P minus this deformed data, then boom, that's going back to the original position and the normal, maybe it's clean data. You see, this is the data we have, and boom. Then now we see there is some kind of data we have, and also you can add the interior detail, RBD interior detail in there, and you can see there's something 0.5 something like that. All right, okay. Point angle here. Which one? This one?
No, the one down there.
The one down there here, and this guy. Before you just get it out here, you can use this normal here. You can get things normal, which is great. Okay, this is fine. Can bring it here. All good. So,
mine's not.
now working. Okay, why is that? Why is that happening? Okay, here.
Yeah.
Because of the because of this. No, you put that this noise here. Second should be here,
Oh, okay.
right?
So 0 would be grabbing the first one, and 1 is grabbing the second one.
Second one is this one, original one.
Right.
You
Okay.
do that here and bring it back here. That is no.
Okay. I got you.
Right? Then you can get it.
What did you do for your interior detail?
Interior detail, because there's a, if you turn off this only, the sleep.
Yeah. Okay, so no exciting for that.
But we can also add RBD between this and
Right. Oh, now, oh, okay. This is working now, but why? Right? That's a question about that. I have to explain a little bit about this. Okay. Let's create the grid pattern here. Grid pattern here. I will explain that what it is here. So let's make that easy to understand that part here, like a third one like this. Okay. Let's check that out. This is a point 4. Okay. This is a point number is 4 is the center. Okay. The point triangle here. Okay. So let me try that this point wrangle here. Just point wrangle 4. And the P dot Y, and that's the 1, for example, here. Okay, point number 4 is up there like this. Original one is like this. Okay. So here, another point triangle is here. How can we bring it back to original position?
Calculate it.
Yeah. We have to calculate between these two, right? This position here. This is a position here. This is a position there, right? That's a gap between, right? This distance we have, okay? So this is actually the plus there, right? So this from there to there is minus y. from here to there plus y, right? This between the two positions. Then we can keep that this distance or position data. We can subtract between them. So that we can store this data in here. This is nothing. This is something. Oh, shape is like this as it is. It's nothing. But if we compare between two, then you can store some data, because let's say we subtract each point. For example, what is it? Point 6 minus this 0.6 is 0, right? This 0, 0, 0, everything is 0, but this one will be maybe something different number, right? So let's try that. It's actually that's a different number it's gonna have. Okay, we deform and p at p minus point triangle plus 1 p 0. Let's see the v deform as. Okay, so everything is, you know, that this position is different here, but you see there's some kind of y-axis. We can check that out, right? Now let's see the p. Everything is, you know, the almost, you know, 0. Oh, what is it? It's something different. Oh, that's everything is minus here. Okay, 0. Oh, okay. So first p minus 0 means, you know, the first input is everything is 0, right? The 0 is 0 point, which is the 0 deform, which is the, what is it? Where is the 0? This 0? I don't know. That's a point where the point position is there. Nothing is happening, then 0. What is the second point? Is the, this is something happened, right? Minus, that's 1. Here, where is the 1? I think that's a different point number here. Something weird here. Okay, we don't need to care about that. This all the data, only the y-axis, because that's only changing part here. This y-axis is different. That's change that between the one position like this, right? This part, which is y here. Is that correct?
Yeah.
Oh, it's not really. Let's put the color on it here.
Oh, okay.
It's something different, right?
Huh? No, I think I just understand why it's the form is giving all those values.
Let's put it. Oh, that's a y and axis and everything. Because everything has create some vector value to apply there. Some kind of, you know, another vector is there. Think something, you know, that's a different. It's not range here. Maybe you can do the range of this.
Everything is comparing to
Length of this deform, then we can compare properly. So that's a we can use that one here. What? Let's see the CD. What? Sorry. That's something is wrong.
is everything comparing to the point 0? Like in the second point triangle. Everything is like point 0 is like point number.
Oh,
Yeah,
oh, sorry about that.
yeah. Is that point number?
Yeah, point number should be.
Okay.
Then makes sense everything there. Oh,
Yeah.
wow, this was really surprising. Thank you for that. Yeah, that's the whole difference, only this part, okay? This one's supposed to be. That's what I expected. Why is not working? Oh
Yeah.
my God. Okay, thank you for that. Yeah. This is a difference between only that part, right? Let's compare between them. Then we can store that. Oh, how can we moving back? Actually minus all the data from there, right? So if you want to do that, if you want to keep that it here, you can put that this one, the P original position equal P minus deform. then we can bring it back, this guy, right?
That makes sense.
Yeah, so that's the things we are between the 2 points, exactly same point number you have to store, right? Exactly should be the same point number. Oh, as I showed that if you put the 0 point number, then that's gonna happen something like this. Different point number has some different result, but the same point number, if you add that, then everything will be fine. This is technique, we just did that here, okay? Let's compare that, this point. Everything is deformed geometry and from the original, and let's store them here. Okay, everything is stored. It's nothing is happening here. But after refracturing everything there and bring it back to the original, then we can get the proper result. Does that make sense to you guys now? All right. Okay. Let's take a break a little bit. Just 5 minutes. Okay.
But
Mm.
a question on just again, it could be wrinkle.
Mhm.
So it shouldn't it be exactly like this?
Yeah, because that's
Oh,
the
is that the
normal.
normals?
Yeah, normal thing. If you
Okay.
add the normal, that will be fine.
Okay. So just a normal then?
Yeah.
Oh, got you.
Mm.
Yeah, I need to use a restroom too.
Sure.
No, I was gonna say that I felt that. I don't know. I didn't do that much, but like what I did was look at this kind of stuff, you know? Just the free tutorials on the D. Oh.
Yeah, when does class end for you?
When this class is end?
Because usually during the evening, the teachers, the evening teachers, they kind of ended earlier than the morning ones, but I mean, it could be different for you.
Yeah, so why is that? Is that because of
It's late and the bus.
the bus? Okay, we can finish that early a little bit. If you want. Yeah.
Well, it's up to you if you still have more than.
It's fine. Then I think this is I think you better the practice a little bit more than that just keep lecturing. So always any course we have, it just you have to practice more.
Yeah.
And that's better. All right, okay, guys. It's a little bit faster, right? But I think that's another one here. Okay, there's another technique. This is the same technique, but what if you want to make this guy like a wood splinter types of shape? How can we do that? Maybe this is an idea we can use it. Same thing. Just let's get the this guy is the same thing as it is. I mean these three. Okay, these three we can add that, and here can add that. Can add that here. Something like that. But this is, as you see, this Bruno reflection. What is the Bruno reflection means actually? That's another question. You guys can see that, right? But here, you see, there's a Bruno reflection scatter point here, and let me just put that this 3 point here, and just turn off. I'll just turn on here, and Bruno reflection. You know, Bornoi is the one of the, I think we do have just two like this, then it's much easier to understand that. But here, this is a point, what that is, right? And here that we have this is a point we have. Okay, let's see this guy here. So we can see that this 3 point made them this change, right? Then let's check this change that out. This 3 point is there. How this guys draw that based on this position? This is Boroi. I think there's a mathematical. Let's check that out. Boroi. Who is Boroi? Google.
It's gonna be like one.
Yeah, that's the thing. So that's gonna be one of the things. Voronoi diagram. Yeah, then you can find that out here. Voronoi diagram is patching of the space into the region where the each region contains the world point cross-set to the one specific seed point of given blah blah something. Right? Here. This is Voronoi diagram. If you want to see that much, then you can get the idea from this guy, which is always useful. You can use this diagram to apply to the other techniques here, but just simply I can draw that what happened here. Oh, sorry. I have to share my screen again. It's still recording now. Okay. Here, station. This is a point here where we have. This is a point where we have. This is a point. Okay. That's gonna be happening here to the line between there. There's another line. It's gonna be there. Another line is gonna be here. Okay. In between the line, that's in the center of this line. Between the line will be here. Okay. Between the line will be here. Between the line will be here. Is exactly center of the line, and it's connect them. Shut up. Boom. Just connect them here. Boom. This is connect them here. So what is the constraint happening? The constraint is actually this. So let's create the constraint. Adjacent. Create the JSON pieces here. It's the name. You think we can write down here? It's the name. Then we can see. Oh, this point is different now. Oh, this is center of the point. Okay, sorry. That's the different. So here, this is point, and this is the one that we have that. I think it's not. Can you get it here? I think there's no more constraint there. Okay, so we do have this kind of Voronoi fracture is happening between the point and the center and the line thereof. Then we can have that one, right? So we can, if you just transform this data, okay, same thing like this, and squeeze them. We will just squeeze them here, and still it will generate this data like this, and just create that. And but if you turn it back, just right click, action, copy reference, and bring it back. Same thing as the noise pattern, but except this right click and invert the transform. Then you can get the some stretching Voronoi fracture here. Yeah, this is just small it down, just change the scale it down, right click, action, to create the reference copy, and bring it back here, and just right click, delete the channel, and just check the invert transform. This is completely opposite. Right? Then you can get some stretching data. Just let me just put that just 10 like this. See 20. Then you can get the some kind of a panel like this, just a little bit longer channel. We can have that. Can you get it? Okay, same thing here. Just pack here. Transform data here. Connect them here, and scale it down. Boom. Okay. And the right click, action, create the reference here, bring it back. Just bring it back to the original, which is the exactly opposite here. Right click, delete the channel, boom. Then you can see here, let's make the a little bit more and just 80 or something. And we can get it and just extrude viewer to check that out. Boom. See? And we can get it.
Not faded.
Huh? And you can apply this guy here as well. You see that? This is like a pattern like a looks like a splinter, right? And just change that so 90 or just less 15, and we can get the more longer one. If you want to make a little bit more the stretching, then you can change that is smaller a little bit more. And we can get the more the longer one. Yeah. Right? Boom. Looks like splinter. Yeah. You guys get it? So now you guys know how to make the shape, the like a splinter and stretching noise pattern on it. This is old school way, still but useful technique. Okay. Right. There's more option. Maybe you can try that with the glass types of the shape. Cracking into the center and just looks like a spider web types of fraction. Can you try that yourself? Try that. Maybe just change the shape on that. This is kind of a homework I gave you. Okay.
Yeah.
So you can try that. And let's moving forward. And just back to character now, right? Now this is a character we have to bring it up. So now we're gonna do the really simple way to make that out because I don't want to get all the detail in here. Just simple fracture and RBD fracture with this we do have. And middle click, there's a polysolve, which is not really polygon. Just convert as it is. Convert geometry and middle click, then you can have that one right here. And that's a Voronoi fracture. Okay. Voronoi fracture is there, but you have to turn off the create the interior surface. Otherwise, this one will get the interior shape that I don't want because this is too heavy. Just uncheck the interior surface and create the scatter point. 1000 will be fine.
And just crash.
Crash it. Yeah, let's wait for it. Exclude the viewer there. This is what you guys need to make it. Okay. Be careful with that. Turn off the create interior surface.
What's the convert node doing?
Convert node make this polysolve to the completely polygon because the now is kind of looks it's not packed, but it's optimized all the data. But this is otherwise it's not gonna work properly. And here, right, scatter 1000 like that. Okay.
Yeah.
1000 something here. Right? Good. Which is good now. And here, what we learned that before, we don't need to just separate the, all the stuff. We do have something like a assemble.
Did you do relax iterations for the?
It doesn't matter. This one is it's up to you.
I'm getting a bunch of holes.
you have a whole thing. Did you turn off the surface? Yeah, I think you know check that out. Oh, then it's gonna work. Yeah.
Oh, right.
Yeah, that's why I'm just saying that don't create any interior surface. Yeah.
Okay.
So here, okay, this is a frac. Okay, and it's another. Oh, why is not put that? Okay, frac. Okay, okay, and create the pack primitives, which is the middle click there. This is 1244. Okay, then we have this kind of stuff, and its character is still moving. Let's see. Oh, the problem is this is a big problem. You know, every frame. What does that mean? You know that.
Slow.
Yeah, every frame, whenever this frame, next frame, this one is create a scatter and fracture again. Next frame, create a fracture. This is not what we want. Okay? That's why what we need to do, we need to have a rest function. Let's check that out. There's a rest function here. Oh, this already looks really heavy. The middle click there, is there any rest function? No. Okay? So we need to get a rest function from there. So I think so go inside. In the production, if you don't have any rest function there, you have to find that out here. This is a mocap data here. I think there's a rest function. T-pose is there, right? And we can use this one for it as a rest function here. But you know that this is smaller than this guy. What happened here? This is something kind of smaller than this. Oh, okay. Right, it's different, right? But without this, maybe you can bring that stuff, but you can still use that one as this first frame you can use as a rest position. But be careful with that. Usually we do use the T-pose as a rest position, but this time it has to use this part. Okay, so time shift here, bring it back to there, and just right click and delete the channel. Okay, that's all. That is all, and bring it that, caching them out. Okay, then pack primitives, and it's moving. It's still, okay. But the problem is, what is the next problem? Is this? It's not moving. Yeah, that's how can we move these guys? Bring it back here.
Actually, we're gonna be like copy.
Yeah, so we can do that. The unpack here and just another one. That's why I'm just separate the pack here. Okay, then here, and we call the point deform. Okay, then bring it back here, and this is a rest position into center, and this is the first one, and last one is the animated one. Then here, then we can see that's the moving, following that. Oh, that's a fractured geometry with the animated. Okay. This is the one. Sometimes it's kind of stretching now, but sometimes it's not. But it's smaller things is gonna happen. But this is fine. Maybe 0.1 or just a longer one. I'm not sure which one is better, but 0.1 will be fine. Okay, that's the things you can do it. And you can bring it that is pack primitives here, and let's see how this guy is working. This is working like this. All right, but before we pack,
Mine is like doing this.
all right, okay, that's the things here. It's a pack, okay, just unpack and pack here. Okay, then we can edge. That's why we do Peg is like a point. That's why it's a point based on point is given. All right, here and let's do here just null. Okay. This is RBD path. RBD source. Okay. Then let's bring this RBD pack here. Just copy them together. Then this one is gonna be the same as this. This one is gonna be same as the what we have here. But we have to copy this guy together, okay? And here, don't just to make that this one just as it is. Just change that this fetch geometry from the thumbnail. Oh, let's see what happened. Play that. Oh, okay. Now we see everything's gone like that. Okay, good. Okay, but it's not moving, right? How can you make that? This character is walking around and slowly just active from top to down. Did you copy that? This one? And bring it back here.
Now.
Yeah, that's okay. You don't need to do that. So you copy them together, that's gonna work.
Oh, true. Okay, well, I definitely. Just to remember, what did we do inside this RDP
That's nothing, just the gravity apply.
right?
This is just gravity apply.
Okay, yeah.
Okay, that's
That's
nothing. But you see, there is a the active, animated, deformed static. If you override that attribute, there's animated and deforming, right? Attribute you can see. We can use this one. Okay. So there's a simple way to make that out. Yeah, we have to keep that deforming geometry, okay? Just point triangle here. Let's say that's a deforming, okay? Deforming is one means, here, this one is not moving, right? But if you on deforming, then it's gonna move. Oh, that's not keep, I don't think so that's the moving, right? But here, okay, let's say here, deforming is moving on with integer. This one should be integer. Other one is the active. Active is 0. I have to apply the active is 0. Means that there's a normal gravity or force will be applied onto inside the thumbnail, but the deforming itself is applied, which is when you play, oh, it is following that, right? But nothing is happening now. So we can apply this just kind of, little bit the time or activation like a top to down here. Okay. So what you can do here, this if condition, you can add that. Okay. Top to down. Maybe y-axis or something number from there. So let's do some number with this guy. This is as if as a add point here. Maybe last time we did that before here. Let's point with the number there, right? This is kind of a random number, but the sort out here from top to down maybe. This is a y-axis here. This is the reverse then it's the 0 to bottom. Okay, zero is top area, bottom is the last number of this point, right? So we can bring it this guy, and we can do that this number. Okay, let's do that. If ptnum is bigger than, what is it? Frame number, for example. frame number, then it's gonna active and deforming is 0. It's just kind of, we can put that opposite way. Here, copy this, bring it that, deforming is 0, is 1, okay? You can do that. So here, from top to down, you know, this one is top is gonna be active, and bottom is not active here. And so play that. It's coming down. Oh, everything is gone here, active, whatever. Oh, what's going on here? Let's check that out. What happened here? Active is 1. Point number frame is 1. Active frame point number is the frame number is bigger than point number. It's gonna active. So what happened here? Let's do that. This one is like a static point here. If that is okay. Something is wrong. Let's check that out here. Have to be geometry is active. Oh, everything. Why this one is everything is active now here? Because this point number is not really the active, right? Active 0. Active is up. Point number is 1. Let's check that out here. What happened? Oh, why this one active is so many actives there? It should be 0. Frame is 1. Active, oh, this is 0. Active is 0 in 2. It should be opposite, right? Let's try that. Point triangle here. Active is 0 here, then that this one active 0. Boom. Oh, still is something wrong. Okay, so it points number is bigger than frame, which is then we active. Otherwise, active is 0. Oh, why this one is happening like this? Should be opposite. Does that make sense to you? Oh, that's something wrong with that. And the point number. This is showing up like this, but I think that's not make sense to me. But it's gonna work here. Yeah, here that's falling down, and it's gonna work. Slowly going down. All right. Boom, boom, boom. Like that.
Wow.
All right.
Mine didn't do that. Mine's does stuff like this. Okay. So here, the same thing as I did here, there will be triangle here, deformer here. Yeah, that's the things that happening here. I think this should be positive. Oh, then it's low. Yes. Yeah, that's all positive. So make it will be.
Yeah, yours is working. It should work. Oh, I think we don't need this part, right? No. No, then oh. Okay. Thank you so much. Oh, it's not changing. No. Forget me over the like say platform. No, this is fun. Oh, yeah, it should be like this.
Oh,
That's yeah, I think this one should be like that. I think this is correct. What?
yeah, I don't know if my sort is right. Am I missing something?
Yeah, this is reverse then. Let's check that out. What happened here? Yeah, this is good. And happen this active here. And bring the active zero. Should be active zero and active one. And you do that. Like that. Huh? Why it's not working? Active. What's going on? That's phone number. Oh, okay. Got it. Yeah, this one is gonna work. Yeah,
Okay,
I'm thinking that's gonna work.
it's like, so that's.
Yeah, and then play the button here and just set the camera a little bit, create the cam here and really? Sure. Go and put down, change that this reverse. Let's here, there's a point number should be top to down. Otherwise, top is bottom, right? Number is different. Then top is shown. Get down. So from here, and we put there, start off.
Mine's not moving.
Did you put that before? It's working right. Can we go inside for the night? Yeah. Go inside and go there. Yeah, override. That is gonna work.
Right.
Yeah, this is the one that and you can make that kind of a start position and make the flip book here. Let's see. Oh, what's going on here? Is it going back? Oh, something's funny. Maybe it's moving back. I think that's the reason why, all right? We need to extend our animation or something. We have to stop there at some point, which is the animation keep coming back, which is this guy is up to here and going back, right? That's the reason why. So what we have to do, a time shift here and bring it back here, and we can make that this last frame as a 52. Okay, this 66. Yeah, this is the last frame. We can set that up. 66. Then it will stop from there. Okay, then you can make it. Let's play that. Okay, let's bring this guy here to flip and flip book for that. Okay, only this part is the. What about the if you want to just completely, breaking? How can you do that? Can you do that?
From the to what? Sorry.
This is only top area only, falling down. This is not complete, fracturing.
I think so.
How can you do that? Can you guys do that to resolve this?
Yeah.
Can you try that now? This is question after whoever is resolve this stuff, then you guys can go home. This is homework like that. Please resolve this stuff.
Do you want both happening or?
Just it's coming down everything, collapsing everything now.
Oh, wait, what?
You know that there's a character is only top area is drifting
The
down,
whole body?
but whole body.
Okay.
Just slowly top to down, okay? Think about that. We know that how to fit it, right? You can also use that the total number of points and fit that and bring that up. Okay. You get it?
I think so.
All right, already done it?
Pardon?
Did you finish that already? Oh, cool. Nice. Just put the frame number there. Oh, that's a good idea as well.
Is that what?
Yeah, that's good. But
Okay.
what if you do that just to make it faster and just skip the number, right? But what about the from the to the center to out? Or
Okay.
what about the just kind of a noise, like looks like noise pattern is the spreading out? How can we do that one? So that's another challenging stuff, right? So let me show you that something here using Pyro source spread here. I mean that this one is the static stuff and Pyro source spread. You're using this one, then you can check that this one or temperature here. Then maybe you can select some grouping here. Let's make some grouping. Let's do thing here. I will just check that out here for select this area. Okay, group. We can call that this guy. We can call this guy as a group. It's called the temp group. Okay, temp group here and the point wrangler there. And let's say this is a temperature. It's 1, and just get the temp group here. Then now we have a oops, sorry. This is temp group. Okay, then now we have this temp group as the color here. Then this is kind of spreading out. Oh, but this is not. So 1 north south and the play. Oh, this is spreading like this. Okay. Can you use this data for the fracturing? Can you apply this too? This is attribute for, there's a burn attribute. You can check that out. This burn attribute is 0, but when this guy is 1, burn is gonna be 1. So we can use this attribute to apply to the what is it? This guy or this guy somewhere. Okay, this one is gonna be really homo to make that out. This kind of spreading with noise pattern activate by this one. This is fundamental of the disintegration. Maybe you can use this technique onto disintegration with the volume, sand effects, or whatever techniques, whatever the solver you're using it. You can use that one. Okay, this technique.